All right, we're back. Last video, and the last time I did this, the audio didn't come through at all, so we're going to try this all over again. So back to my screen, share that with you. All right, we're back to this GeoGebra, and what we're going to do in this video, the final video, is to I'm going to show you how to create your sine waves. And the sine waves are a way of representing the rotations of all of your vectors. Now, it turns out we're not going to have every vector matched up with a sine wave. That would be a lot. But we are going to put quite a few in. So I want to get you started with how to create sine waves. What you'll want to do is go through your algebra list and look for Z1. When you started creating points, the vector points, we used the Z1, Z2, and so on. Notice Z1 has an e to the it. That's actually 1 it, and this is negative 1 it for Z2. We're going to start with those two. Every point Z basically was created to rotate either clockwise or counterclockwise around the origin. And they all are a different distance away from the origin. And they all have a different starting angle. So what we're going to see is all of those characteristics are going to be seen in the sine waves themselves. So let's get there. Down here in the input window, parentheses, T. So we're making a new point, T, comma, x of Z sub 1. And what does x of Z sub 1 look like? Let's get this out of here. It's a point R. Now, if I look in here, let's get rid of the curve. Somewhere there's a point R. And it's at 4.38. Okay, so I need to zoom out. 4.38. I was really zoomed in. There it is. Okay, so we're going to now take this point and see if we can get some kind of a wave out of it. Because what we're really doing, we took the x coordinate. Remember the x of Z1? So when you are projecting on the x-axis, what you're really doing is following, what is the x coordinate? The cosine. So the cosine, when you graphed it, remember, makes a sinusoidal wave, and that's what we're going to get. So we're going to use this right here, this command locus. Basically, you choose that tool, go over here to the point you just created, and then click on the slider T, enter. And there you have it. Okay, there's our first, for me, that's what my very first point, Z1, which rotates in a positive, well, actually, so that would be a counterclockwise direction. Notice it goes to 6.28, which is 2 pi. That's one. Remember, 2 pi is 1 full rotation. And it actually looks like it pretty much starts here and that's 1 cycle, or one period, right? So 1 period spans 6.2i or 6.28 or 2 pi. All right, so we can hide a label. I'd like you to color these to help you differentiate between different kinds. Yeah, let's get to this. We're gonna make it red, okay? And I hide the label. And if you move T, you notice point R slides along that curve. So that curve is really just the locus or the set of all points covered by the point R. Now, likewise, we're going to basically continue to repeat this idea. In the input bar, it's T, comma, x of, now Z2. Now Z2, if I showed you earlier, Z2 is the -1 frequency. It corresponds to the -1. So enter, and I get this point S. And the S will also move according to the slider t. It depends on the time. So go to the locus tool, click S, click T, and there you have it. And that's nice. It made it red. And I like these both to be red because one has a positive one frequency, the other one has a negative one frequency. What they have in common is they're both the same wavelength, right? They do one full cycle over a period of 2 pi. Now, keep this going. We're going to go parentheses t, comma, x of z3. Now, if I showed you up here, let me hit enter first. That gives me a point t. Here's here. But what is z3? If I can find it, z3. There it is. Look, it has a 2. And Z4 has a negative 2. And that's pretty much the pattern. Z5 will have a 3, Z6 will have a negative. Z5 will have a 3, rather. Z6 will have a negative 3. So I'm going to go back to the point T. Well, let's choose locus, T, and then a little t, lowercase t. Now, I don't want this one to be red. I'm going to make this one on T, this locus, different color. Hide the label. Make this one blue. Okay. Why? Because it's a different frequency than the red one. The red ones did one full wavelength in a span of 2 pi. This is doing 2 full wavelengths, you can see, right? That would be pretty much the end of 1 and then 2. So let's do the next one. T in the parentheses, t, comma, x of, whoa, let's go back. What happened? I don't even know what I did there. So let's go back. Delete. I think I was on the locus tool. So delete, try that again. Yeah. So, and it deleted that locus. I didn't want to delete that locus. So back over here, T. And we're coloring it blue. Let me fix what I just did. There we go. Hide the label. All right, try that again. Parentheses, T, comma. See, the x-axis is really what I'm referring to as now the t-axis, or the time axis, right? And we want x of z4. That came in as u. We'll do a locus with u. And it put it in as red. Yeah. So it doesn't always go in the color you want, so we'll go over here and make it blue. Okay, so that's the idea, right? And what I want you to notice about this is these have relatively the same amplitude. They're not exactly the same. This one's a little higher than this one. But what's really similar to these in these two blue sine waves is that they have the same frequency, right? They do 2 full cycles. Both of them do 2 full cycles. The difference between the one and the other is one rotates at a negative frequency. In other words, it rotates in the clockwise direction, and the other one has a positive rotation or counterclockwise. They also have different phases, which means that the angle they formed when I created the vector off the origin is at a different starting angle, and that's indicated by the phase shift. So all of these, this is capturing what all the different phases and amplitudes and such. Okay, so we're gonna now go one more just to get you hopefully you're getting the hang of it now. X of z5. All right, where's v? Right there. So now I'm gonna go to locus, v to the t. You notice it's even, and I don't want it to be blue because it's got a frequency of 3 now, so we'll make it green. And it's got a little higher amplitude than this blue one and this blue one, but it's less frequency. Amplitudes are going to vary, right? Where all of these will be looking different for each of us. We have different images. And we should do one more, and then we'll call it a wrap. Now, I'd like you to go up to 10. Okay, so up to Z, that would actually be Z20, right? So start doing these. They don't take that long, really. T, comma, X of Z. Whoa. X of Z, what? Subscript. 1, 2, 3, 4, 5, 6. Z6. W. Okay, so we got to be careful here. One is locus. Which one is T? Which one is W? It's hard to tell. Okay, so another way you can do locus is just go here and then click W, and then click T. Yeah, that worked. Now, which one is it? It goes to W. It's this one right here. Yep. So I want to select that, and I'm going to make it green. Okay. So the greens have the same frequency. The blues have the same frequency. And when you get up to 10, you're going to see it. It does 10 cycles. Like the green just does 3 cycles in this span, right? 10 will do 10 cycles in it. So that's the idea, okay? And once you have all of your sines, all your sine waves, you're done. This was the whole idea of the project, is to make the connection between the way of fitting a curve using sinusoidal motions, which basically are circles. The sinusoids are just reflections of those circles on the x-axis. Okay, so we'll end the video there. Hopefully that wraps things up for you. We will cover any questions in class this week.